Hello guys, this lecture of engineering mathematics on topic higher order linear differential equation is brought to you by lecturesforfree.com. Hey guys, this is the 7th lecture of this differential equation series. If we haven't seen earlier part, then I will recommend you to watch that also. So now first of all, let's check out what are the topics that we will cover in this lecture. In this lecture, we will see the definition and standard form of higher order linear differential equation. Then we will see the procedure to find out the solution of higher order linear differential equation. Then we will see what is auxiliary equation, what is complementary function and particular integral. Then in this lecture we will see the different type of complementary functions for different roots of auxiliary equation. In this lecture we will cover basically the complementary function. In the next lecture we will see the particular integral section. Okay, after that we will solve some gate questions related to this topic, and for more gate questions, for more solved gate questions, you can download it from my website lecturesforfree.com, and you can download my handwritten notes there. There are some more solved gate examples are there. Okay, then at last there is a challenge question for you in this lecture. If you can solve that, then give me the answer in my comment box. Okay, if you can't solve, then I will tell you in my next lecture. Okay, so let's start. Sorry. Higher order linear differential equation, it is in which the dependent variable and its derivative occur only in first degree and are not multiplied together. Thus linear differential equation of nth order is given by. Okay, so higher order linear differential equation means where dependent variable, as we have seen earlier, means dy upon dx means y here is a dependent variable and x is the independent variable. So dependent variable and its derivative should occur in first degree. Okay, means either it's y or dy by dx or d square y upon dx square, it should always be occur in first degree, means their power should be 1 in every term, their power should be 1, or and not multiplied together. So it not, if it will be multiplied, then definitely their power will be more. So standard form is like this: d to the power n y upon dx to the power n plus k1 dn minus 1 y dx to the power n minus 1, like this. Standard form will be like this. Okay, here k1 k2 k3 k4 kn, these are the constant k1 k2 and so on kn, these are the constant. Okay, for some cases it may be function of x also. For some cases it may be function of x also. Okay, and here capital X, this capital X is also the function of x only. Capital X will also be the function of x only. Okay, so we can represent like this: d, and here k1 k2 kn are the constants, or it, for some cases it could be the function of x also, and capital X is the function of x only, or it may be many cases it may be 0 also. 0, it could be 0 or it could be function of x only. Okay, so let's go next. And to solve this type of question, means to find out the solution of higher order linear differential equation, we represent it in some other format. What we will do, we will replace d upon dx with a new operator called d. Okay, and d square upon dx square by d square. Okay, and similarly so on, d to the power n upon dx n, we will replace it by d to the power n. Okay, so we can represent this standard form in the form of capital D. So we can write it as a d to the power n, d to the power n plus k1 d to the power n minus 1 plus k2 d to the power n minus 2 plus this kn. Okay, yeah, okay, d upon dx is d, na? So here we will write dn y and k1 dn minus 1 y, k2 dn minus 2 y, and kn y, and that will be equal to capital X. Okay, you can take y common here, so it will be like d to the power n plus k1 d to the power n minus 1, k2 d to the power n minus 2 plus so on kn, and you can take y common here, so y, and it is capital X. Okay, so this is the function of d, this is some function of d. So you can write it like this: function of d into y is equal to x. Okay, so you can write your higher order linear differential equation is like this: function of d into y is equal to x. Okay, so now to find out solution of this, we will to find out solution of this now, f d y into 0, we can write the solution of this like this, like y is equal to, like we can write the solution of this equal to y is equal to u plus v. Okay, here y represents the complete solution, okay, and u represents the complementary function, okay, y represents the complete solution, u represents the complementary function, and v represents the particular integral, Okay, so basically your complete solution is the combination of complementary function and particular integral. Okay, so your equation is like this: function of d into y is equal to x. Okay, here y represents the dependent variable, it could be x, it could be some other name also. Okay, y represents the dependent variable, here y means dependent variable. If in any question dependent variable will be x, so here it will come like a x is equal to. Okay, so your equation is this, and the solution of complete solution of this is dependent on two things: complementary function and particular integral. So complementary function we will get from this function of d. Okay, complementary function we get from function of d, and particular integral we get from x. Particular integral we will get from x. So for if any equation, if capital X is equal to 0, if for any differential equation capital X is equal to 0, means equation is like this: f dy is equal to 0. So since capital X is equal to 0, means there will be no particular integral, because particular integral is depending on the this x. If it is 0, means particular integral will be 0. So for this type of question, your complete solution y will be only the complementary function. In this type of question, particular integral will be 0, so complete solution y will be the only complementary function. Okay, So now let's see the steps to find out the solution. First step is get the auxiliary equation. Okay, let's see what is auxiliary equation. AE represents the auxiliary equation. AUXILIARY, auxiliary equation. If any differential equation is given, then we can convert it function of d into y is equal to x. We can convert that equation like this. Okay, how we can convert? By replacing d upon dx to capital D, d square upon dx square to capital D square, and so on. So we will get a function of d into y is equal to x, capital X. Okay, so here if we will put function of d is equal to 0. Okay, so now we got one equation. Now we got one equation of d, capital D. This equation is known as auxiliary equation. This equation is known as auxiliary equation. So our first step is to get the auxiliary equation. Okay, means replace the d by dx or d by any independent variable by capital D and get the auxiliary function. What is auxiliary function? Function of d is equal to 0. This is auxiliary function. Okay. Step 2 is find the roots of auxiliary function. Okay. So now you got one function is equal to 0. Like let's suppose example d square plus d plus 3 is equal to 0. Let's suppose it is a function of d that is equal to 0. So from this we will get roots of this. Roots of this means the value of d which satisfies this equation. Okay, so roots will be depend on the order of this differential equation. If it's a second order, then you will get 2 roots. If it's of order 3, then you will get 3 roots. Order 4, then you will get 4 roots. Okay, so solve this question and find the value of d for which this equation is satisfied. They are called the roots of that auxiliary equation. Now step 3rd is get the complementary function. So by observing these roots of the characteristic equation, by observing the roots of auxiliary equation, we can get the complementary function. How we can get the complementary function by roots of auxiliary equation, that we will see in my next slide. Okay, for now just assume this, that complementary function we get from roots of auxiliary equation by observing the roots of auxiliary equation. How we will get it, we will see in our next slide. Okay, so you get solution, you get the complementary function of solution. Okay, now next step is get the particular integral if necessary. Okay, as I mentioned earlier that for a equation like this, f dy is equal to 0, if this capital X will be 0, then particular integral will be 0. So don't need to calculate particular integral. For this type of question, your solution will be only complementary function. So we have to get the particular integral only if it is required. Only if it is required. Otherwise, we don't need to calculate particular integral. In step 3rd, we will get the complete solution if our equation is like this. If function of dy is equal to 0. Okay. Now find the complete solution. Okay, so what will be our complete solution? Our complete solution will be complementary function plus particular integral for case when f dy is equal to x. Okay, if function is like this, and the complete solution will be only complementary function when our equation is like this, f d is equal to 0. Sorry, f dy is equal to 0. Okay, so these are the steps. Now we will now let's see how we can calculate complementary function by observing the roots of auxiliary equation. Here you can see, here roots are given in left hand side, okay, and in right hand side complementary functions are given, okay, corresponding to that roots. Okay, so let's consider first case. In first case there are real root and different roots. Let's suppose you got m1, m2, m3. These are the some real numbers and they all are different. Means m1, m2 and m3, these are different and real numbers. Then you will get complementary function like this: c1 e to the power m1x, c2 e to the power m2x, c3 e to the power m3x. Means for each real root you got one constant c1, c2, or for each real root you got one constant and one exponential term, okay, e exponential term whose power is that real root m1x. For m2, c2 e, then m2x, e to the power m2x. So for each real root you get a constant and one exponential term like this, and you will get that real root in exponential power. Okay, now consider the second case. In second case, when two real roots are equal, okay, two real and equal roots. Now you can see this m1 m1, these are the two roots but they are equal, m1 and m1. Okay, so and there are third root is like m3, it is different, third root is different, but there are two equal roots m1 m2. So you will get like this: c1 plus c2x, then e to the power that equal root means m1x. Okay, two roots, so you will get two constant c1 and c2, but they are equal, so you will get a function like this: c1 plus c2x, and this whole thing is multiplied with the exponential term whose power is that uh, real and equal roots. Okay, for this, and for different root there is a same as above, the m3 is different, so for different root is like our earlier. Okay, now next consider the third case. There are three real roots and they three roots are equal, means m1 m1 m1, and then there are different root m4. Okay, so there are three roots and they are equal, so we can write the solution like this: c1 plus c2x plus c3x square, and this whole thing is multiplied by the e1 to the power exponential to the power m1x. M1 means that real and equal roots. Okay, and this m1 m4 is different, so you will get a separate term like this: c4 e to the power m4x. Okay, now let's consider the next case. When you get a pair of imaginary roots, imaginary terms you will get generally in pairs. Okay, because imaginary terms you will get like square rooting some negative numbers, so you will get plus minus terms. Okay, so let's suppose you got like this: alpha plus I beta and alpha minus I beta. Okay, so for alpha plus I beta and alpha minus I beta you will get a complementary function like this: e to the power alpha x, means e to the power real part of that imaginary pair, and x, then one constant c1 cos beta x, means imaginary part and x, plus c2 sin imaginary part beta and x. Okay, like this, and this m3 is some real roots, so for m3 you get like this. Okay, then one separate term. Let's suppose now you get two pairs of equal imaginary roots. Now this was the single pair of imaginary roots. Now let's suppose you got the two pairs, means alpha plus I beta two times and alpha minus I beta two times. Okay, so you will get like this, as we have got in my earlier, like e to the power alpha x, it will be common, and here in place of c1 you will get c1 plus c2x and cos beta x, plus in place of c2 you will get c3 plus c4x into sin beta x. Okay, and here m5 is some different root, so there is a separate term for m5. Okay, now for a pair of irrational roots, irrational where like this, alpha plus root over beta and alpha minus root over beta, where root over beta is like irrational numbers. So you will get an equation like this: e to the power alpha x c1 cos hyperbolic root beta x plus c2 sin hyperbolic root beta x. Okay, so if you got the idea, um, so we can start solving question. If you haven't got full idea, then also observe some question, then you will get more idea. Okay, so let's see some gate questions related to this topic. uh, so here you have to find the solution of ordinary differential equation d square y upon dx square plus dy upon dx minus 6y is equal to 0, and you have the four options given here. So to solve this question, we can convert it into a function like this: f dy is equal to capital X. We can convert the given equation is this in this type. How? By putting d upon dx is equal to d, and d square upon dx square is equal to d square. So your equation will be like d square y plus d minus 6 y dy होगा, dy minus 6y is equal to 0. Okay, here x is your 0. So in this question we have to find only the complementary function. We don't need to find particular integral because here capital X is 0. Okay, so you can write it like d square plus d minus 6 into y is equal to 0. So now your equation is like this. Now first step, get the auxiliary equation. So this is your function. So auxiliary equation is your fd is equal to 0. So what is your function of d here? This is your function of d square plus d minus 6. Let's put it 0. So you will get d square plus d minus 6 is equal to 0. So you will get d square plus 3d minus 2d minus 6 is equal to 0. So you will get d in d plus 3. Here you will take common minus 2. Then you will get d plus 3 is equal to 0. So you will solve it. Then you will get d plus 3 and d minus 2 is equal to 0. So you will get roots of this equation is like minus 3 and plus 2. Minus 3 and plus 2. These are the roots of this differential equation. These are the roots of differential equation. So here we got real roots, and these real roots are the different. So this is like a first case. When you got real and different roots, then you will get term like this: c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x. So as it is the second order equation, so you got two roots, and these roots are real and different. So you will get complementary function like this. Complementary function is equal to c1 e to the power minus 3x. Okay, m1x means m1 is here. Let's suppose this is m1, this is m2. So c1 e to the power m1x means minus 3x plus c2 e to the power m2x. m2 is your plus 2. So you can write it 2x. So this is your complementary function. So your complete solution means y, because y is here a dependent variable. Y is equal to complementary function means y is equal to c1 e to the power minus 3x plus c2 e to the power 2x. Okay, so you got this equation is your complete solution. Now see the options and see which option is correct. So now here you can see option C. In option C you are getting the same term. So for this question right answer is your C. Okay, this question is asked in GATE 2010 for 2 marks. Okay, so here you can see this question is very simple for 2 marks, and this question is also asked in 2010. Now let's see the another question. This question is asked for 1 marks in GATE 2008. Okay, so given x double dot plus 3x is equal to 0, this is given. Here I think you are familiar with this term like x double dot. Okay, x double dot means double differentiation of x, d square x. Here you can, here dependent variable is your x. Dependent variable is your x. Here independent variable is not given, but we can assume it like t. Let's suppose your independent variable is t. So here x double dot is written. It means d square upon dt square like this. Okay, so you can replace it with d square. So you will get like a function like this: d square x plus 3x is equal to 0, or you can write it as a d square plus 3 into x is equal to 0. Okay, so you got this. First of all, let's see the question again. Given you have given one equation, and conditions is given. Condition is given like x0 is equal to 1, and x dot 0 equal to 0. These two conditions are given. Okay, generally in this type of question, conditions are given to find the constant terms. Okay, as we know, in solution of this question we will get constant like c1, c2. So to get the value of that constant, these conditions are given in this question. Okay, and in this question you have to what is asked, what is the value of x1? Your x1 value you have to find out. You have to find out the value of x1. So to get the value of x1, you have to first find the equation of x. You have to first find the equation of x. Then you will put the t equal to 1. Then you will get the value of x at 1. Okay, so to get the equation of x, that means the solution of this equation. Okay, now this equation is like f d x is equal to 0. Okay, to get the solution of this equation, let the first step is your find the auxiliary equation. Okay, so what is our auxiliary equation? F d equal to 0. What is our f d here? D square plus 3. Okay, so let's put it 0. So you will get d square plus 3 is equal to 0. So from here you will get the root of auxiliary equation, d square is equal to minus 3. So you will get d is equal to plus minus root 3, because here minus sign is there, so you will get term like I. Okay, so this is a, or you can write it like this also, 0 plus minus root 3 into I. So it is like you are getting root like alpha plus I beta and alpha minus I beta, where alpha is equal to 0 and beta is equal to root 3. Okay, so in this case you will get solution like this. Like here you can see, if you will get a pair of imaginary roots, then you will get solution like e to the power alpha x and then c1 cos beta x plus c2 sin beta x. You will get solution like this. So now your complementary function will be like this, where alpha in this question is alpha is 0 and beta is root 3. So your complementary function will be Your first step has been done. Okay, you get the auxiliary equation. Second step, you got the roots of auxiliary equation. Third step, by observing the roots, you are getting the complementary function of the equation. Complementary function will be e to the power alpha x means 0 into x, here alpha is 0, plus c1 cos beta x. Beta is your root by root 3 here, so root 3. But x here we will not write x, because here x is written means x is here x is representing the independent variable. Okay, x is representing independent variable. So in this question, our independent variable is not x. Our independent variable is t. In this case, our independent variable is t. Yeah, here x is your dependent variable and t is your independent variable. So you will get a root 3 into t, not x here. Okay, and here also e to the power 0 into t. Okay, similarly you will get c2 sine root 3 into t, because here you will write independent variable. Okay, and okay, so you got the complementary function. Now in this question you don't need to find the particular integral, because this question is like your function of d. X is equal to x is here dependent variable is equal to 0. So here right hand side is 0, so you don't need to find particular integral because it will be 0. So now the complete solution equal to dependent variable. Here dependent variable is your x, so you will write x is equal to, not y is equal to. You don't write y here, because here x is your dependent variable, so you will get solution like x is equal to. So x is equal to complementary function, so you will get like x is equal to c1 cos root 3t plus c2 sine root 3t. Okay, so now this is your complete solution. Okay, this is your complete solution, but here you don't know the value of c1 and c2, so you cannot calculate value of x1, means you cannot calculate the value of x when t is equal to 1, because you don't know the value of c1 and c2 till now. So to get the c1 and c2, let's apply the initial condition that is given in the question. What is initial condition given? x0 equal to 1, x dot 0 is equal to 0. Okay, so let's apply x0 is equal to 1. x0 is equal to 1 means, here it's given x0 is equal to 1. It means your value of x is equal to 0 at t, your value of x is equal to 1. Value of x is equal to 1 when t is equal to 0. So you have the function of x here. Okay, so put t is equal to 0 and x is equal to 1. Put t is equal to 0 and x is equal to 1 let's suppose write it as a equation 1 here, equation 1. So put t is equal to 0 and x equal to 1 in equation 1, so you will get x is equal to 1, so you will get here 1 is equal to c1 cos root 3t. We are putting t equal to 0, so you will get cos 0 here. Cos 0 means 1, so you will get c1. You will get c1 plus, next is c2 sine root 3t. Okay, so if you will put t equal to 0, so you will get here sine 0. Sine 0 will be 0, So this whole term will be 0. So plus 0 plus 0. So here you will get value of C1. C1 will be 1. C1 equal to 1. Okay. Now you got this. C1 equal to, you got the value of C1 now. So now find the value of C2. Okay. So to find the value of C2, let's apply the second initial condition. So our second initial condition is x dot 0 is equal to 0. So here x dot means representing the first differentiation of x dot 0 equal to 0. Okay, means we have to differentiate our equation x. Okay, this is the equation of x, not x dot. X dot means first derivative of x. So we have to differentiate this equation one time to get the x dot. Okay, so let's differentiate that equation. Then you will get x dot equal to, if you will differentiate that equation, then you will get x dot equal to root 3 common, and c1 cos root 3t. So cos, the differentiation of cos is minus sign, so minus c1 sine root 3t plus then sine term is there, so differentiation of sine is cos, so you will get c2 cos root 3t. Okay, so you got x dot equal to this. So now you have, your condition is like x dot 0 equal to 0. It means x is equal to 0 when t is equal to 0. Okay, so let's apply this condition in our this equation, x dot equation. So you will get 0 is equal to root 3 into sine t. If you will put t equal to 0, then sine 0 will be 0, so this term will be 0 plus c2 cos root 3t. So here if you will put t equal to 0, then you will get c2 cos 0. Cos 0 means 1. So you will get c2 into 1. So you will get c2 is equal to 0 here. So now you got the value of c1 also and you value of c2 also. And you have to find the value of x at, you have to calculate this value, means x1. Okay, sorry, x1 means we have to calculate the value of x when t is equal to 1. So to calculate this, let's get the function of x by putting this value c1 equal to 1 and c2 equal to 0. So put these two value in this our equation number 1. Okay, so you will get x is equal to, you will get x is equal to, c1 is equal to 1 and c2 equal to 0 we have to put. So you will get x is equal to cos root 3t. Okay, so now you got the x, so you can calculate x1, put t equal to 1 here, so you will get cos root 3. If you will solve it by calculator, then you will get cos root 3 is equal to 0.99. So now from the options, let's see in which option you are getting this. Okay, so now here you can see in option D you are getting the same option, same answer. So for this question, your right option will be option D. Option D will be your right answer. Let's see one more question. This question is asked for 2 marks in GATE 2005. Okay. Here also you have given one equation. Okay, the complete solution of the ordinary differential equation d square y dx square plus p dy by dx plus qy is equal to 0 is, means in this question you have to in this question complete solution is given to you. Complete solution is given to you and you have to calculate the value of p and q. So as you will observe this question, and if you will convert this question like this, f dy is equal to 0, by putting d by dx is equal to d square upon dx square is equal to d square. Okay, so we can observe this equation is here x is equal to 0, so only you need to calculate complementary function to get the complete solution. So y equal to complementary function. Okay, so you don't need to calculate this because it is already given you, that is y is equal to c1 e to the power minus x plus c2 e to the power minus 3x. Okay, so by uh, observing this solution, you can guess the value, the roots of auxiliary equation. Okay, as you will observe it, then here you can see the term that is here means -1 and -3. These are nothing but the roots of auxiliary equation. Okay, so you can write, you can get the roots of auxiliary equation from this answer. So you can also write the auxiliary equation. Okay, so first of all, let's write the roots of auxiliary equation. By observing the answer, you can guess the roots. Roots will be d is equal to -1 and -3. So you roots are like this. So by this root you can calculate the auxiliary equation. How you can calculate? If roots are like this, then terms in your auxiliary equation will be like d plus 1 is into d minus 3 is equal to 0. Why? Because if you will solve this question, then this equation, then only you will get these roots. Okay, I think you can understand it. Like d plus 1 equal to 0 means d is equal to -1 and here it will be plus. D plus 3 is equal to 0 means you will get the d plus 3 is equal to 0. So here you will get under root d is equal to -3. So you can create auxiliary equation by observing roots. Okay, so now simplify it means now get it in like this. So d square plus 3d plus d is plus 3 is equal to 0, or you can write d square plus 4d is equal plus 3 is equal to 0. So this is your auxiliary equation. This auxiliary equation you got from the solution given. What solution given? Solution y is equal to c1 e to the power minus x plus c2 e to the power minus 3x. So from this solution you got this auxiliary equation. Okay, now from the given differential equation means this d square y upon dx square plus p dy by dx plus qy equal to 0. Now get the auxiliary equation from this differential equation. Okay, and compare it. Then after that we will compare these two auxiliary equation. By comparing that we will get the value of p and q here. Okay, you have to calculate the value of p and q. So let's find out the auxiliary equation from the differential equation. So if you will write this equation like this, f d y equal to 0, so you will get the equation like this, means d square y plus p d y plus qy is equal to 0, or you can write it like d square plus p d plus q is equal to 0, sorry, into y equal to 0. So here you will get auxiliary equation is equal to d square plus pd plus q is equal to 0. So now you can compare this equation 2 and this equation 1. This both represents the auxiliary equation of same equation. Okay, so now here you will get, if you will compare this, then here you can see p, here you will get, you can see 4. So you can assume, you can guess that p equal to 4, and here the term is q, here it is 3, so q will be 3. So now let's see the option, in which option you are getting p is equal to 4 and q equal to 3. P is equal to 4 and q equal to 3. So here we can see option C. In option C, you are getting the right option. So for this question, C option is correct. Okay. So now there is a challenge question for you. Okay, guys. In this question, y double dash plus 2y double dash means the double differentiation of y plus 2y dash plus y equal to 0, and some initial condition is given to you. Okay, and you have to find out the value of y at 0.5, at x equal to 0.5, or you can say t equal to 0.5, whatever you want. So here also, to get the value of y, you have to find out the equation of y. Okay, so try to solve this question, and you got the answer, then give me the right answer in my comment box. Okay, guys. So if you want to see the more solved examples, then you can download my handwritten notes from my website lecturesforfree.com, and if you have any doubt, then you can ask me there also, and you can ask in comment box also, and you can follow us on Facebook, Twitter, and please subscribe our channel, and if you like this video, then like us. Thank you, guys.